So there are two ways that scientists have studied our Earth's climate over time. Dendrochronology and ice cores, and we're going to look at ice cores in this video. There is ice in several different locations around the world for us. So here's our Earth. Where you have mountainous regions, there is ice in the form of glaciers, like rivers of ice in mountain areas. That's not where scientists get the ice cores from. There is also ice in the Arctic on top of the sea, so we call this sea ice. That is not where scientists get the ice cores from. There is also ice on top of land in Antarctica, at the South Pole, Antarctica, and Greenland in the Northern Hemisphere. Ice on top of land is called an ice sheet. So when scientists are studying the Earth's climate using ice, it's ice from ice sheets in Greenland and Antarctica that they study. So why do they study the ice sheets to look at the Earth's climate? Well, an ice sheet is made by falling snow. Here's some snow. Snow falls very irregularly, very infrequently, so not very often, in Antarctica. But when it does fall, it falls to the ground. And it builds up a layer of snow, and in that layer there are also air bubbles. So there's a layer of snow and there's a layer of air bubbles. And then it snows again. And it builds up another layer of snow with air bubbles in it. And over hundreds, over millions of years, those layers build up and up and up and up. So we've got hundreds, thousands of layers of snow, which has now become ice. The snow becomes ice over time, with air bubbles in it. Each layer has got air bubbles and snow. Now, in these air bubbles, well, where's the air come from? When the snow fell, air surrounding the snow, air in the atmosphere at the time, was caught in these little bubbles. So these bubbles contain bits of the Earth's atmosphere at the time. Let's just recap what an atmosphere is. Here's our Earth. An atmosphere is a layer of gas that surrounds a planet, in our case, Earth. So the air that we breathe around us, that is part of the Earth's atmosphere. So when an ice sheet forms, bits of atmosphere get caught up in the ice sheet in bubbles. And along come the scientists. Now the scientists take a large drill. Here's our drill. And they drill down through those layers of ice. Here's our drill, drilling down through the layers of ice in the ice sheet in Antarctica. Then they take the ice out section by section. So you drill down and you drill a core of ice. If you've ever used an apple corer, you can push it into the apple and it creates a hole, but it keeps what's inside the hole. So when scientists drill through the ice sheet, they get an ice core. And the ice core is just a cylinder, a long cylinder of ice. Then the scientists look very closely at the ice core. So here's a magnifying glass. They use much more sophisticated equipment, but they're looking at the ice in the ice core. And what they're looking at is the bubbles. Now, why are they interested in those bubbles? Well, remember that when the ice sheet formed, there were layers of snow with bits of the Earth's atmosphere caught between them that ended up as bubbles in the ice sheet. So when scientists get their ice core, they look at those bubbles and they want to see what gases are in those bubbles, because that will tell them what the Earth's atmosphere was like at the time. If they look at the bubbles closest to the surface of the ice, at the top of the ice, that tells us what our most recent atmosphere was like. But if they look at the bubbles right at the bottom end of the ice core that they've drilled, that tells us what the atmosphere was like millions of years ago. So by comparing the Earth's atmosphere today to the Earth's atmosphere 2.7 million years ago, which is the longest the longest record we've got from an ice core, we can tell if there are more greenhouse gases in the atmosphere today. And then, by combining ice cores with other records like tree rings, like dendrochronology, and temperature measurements that people have made themselves, we can see whether what's happening now is normal, which we know it's not. The increase in temperature that's happening now has never happened before. And we can also see what the effects of our increase in temperature might be. So if we know, millions of years ago there was a very high amount of carbon dioxide in the atmosphere, and we know what effect that had at that time, well then we can guess now, if we have that same level of carbon dioxide in the atmosphere, what will the effects be today? The final way that scientists are looking at our Earth's climate today is with temperature measurements. In the past, since about the 1850s, people used thermometers, and this is a thermometer, to measure the temperature of a specific place at a specific time. Now our technology's got a lot better. So here's our Earth. Surrounding the Earth are satellites, and they orbit the Earth, they fly around the Earth. And they look at the Earth, and satellites can measure the Earth's temperature. And one satellite will fly all the way around part of the Earth. So scientists can look at satellite data, what satellites are seeing, to measure the temperature of the entire Earth. So we can combine satellite measurements of temperature with ice cores, with tree rings, with dendrochronology, and we get to start to build up a picture of what the Earth's climate was like and what it might be in the future. It's a bit like a jigsaw. So you've got the tree rings, but they're not that accurate. There's bits of the record missing, so you need to add it to another piece of the puzzle, which is ice cores. But again, sometimes ice cores don't tell you everything that you want it to, so then you have to add it to another piece of the puzzle, and that is satellite measurements of temperature.